Hey guys, welcome back to CHEM. As promised, this is going to be a video on how to make lead iodide. Something that I call pretty chemistry because this is really just beautiful to watch, the reaction. And lead iodide itself, once you extract it from the solution, it is just a gorgeous material to look at. That being said though, and as I mentioned in some of the previous videos where I showed you how to make the reactants, it's not the most useful chemical in the world, but this reaction is cool enough, at least I thought, and I thought that it warranted a video on showing you guys how to do it, because this is just something relatively easy and fun that you could do at home. If you have kids, your kids would love to see it. However, I should mention though, as a little disclaimer here, that we are going to be working with lead salts. And I'm sure, as you already know, lead itself is toxic. However, the lead salts are even more so because they are broken down into basically a powdered form of lead that can be absorbed through the skin, ingested, breathed in. So use caution when doing this procedure or when working with any type of lead salts. That being said, we can move on here to our synthesis. So what I have here is just an Erlenmeyer flask with 500 milliliters roughly of distilled water, and we are heating that up. I will throw a stir bar into it here momentarily. And then we have our two reactants right here. I showed you how to make both of these in previous videos. This here is our potassium iodide, and I have pre-weighed out 1 gram. And this is our lead nitrate that we made. And what you're looking at is just half a gram of the lead nitrate. So you may notice right off the bat that we have about a 2-to-1 ratio of the potassium iodide to the lead nitrate. So the potassium iodide is being added in extreme excess here. It's just to make sure that all of the lead nitrate gets reacted, and there's no other reason for it than that. As long as you have the potassium iodide in excess, meaning more of it than you have of lead nitrate, this reaction should work splendidly. Now, I would not recommend going more than 1 gram of the lead nitrate. The reaction will still work. However, the chemical that is produced takes on different characteristics when it is made in mass as opposed to just made in a little tiny amount. And I think that the actual visual effect when it is made in a very small amount is much more stunning than it is when it is made in larger amounts. And I will get into exactly what I mean about that once you see the reaction start to go off and see how it actually works. And then you will be able to understand better what I mean about why it is best to perform this experiment with the least amount of lead salt as possible. So now we just have to wait for our water to heat up. You want to bring it to, if not boiling, around the boiling point, because this reaction is, well, the reaction itself is not really affected by the heat so much, but the effect that we are trying to produce here is directly affected by heat, and the cooling process. So what we want to do ideally is we want to get our fluid here, which is our distilled water, as hot as possible, which, as I said, it should be up at around boiling point, so you're talking 100 C or 212 Fahrenheit. And then we can start adding our reagents to it, or reactants, whatever you want to call them. They're chemicals, is what they are. Now, on a side note, and please, anybody out there that knows more about what they're talking about than I do, feel free to correct me in the comments. I do not want to be giving out misinformation. That being said, as I understand this, and please mind you all that I am a 100% self-taught hobbyist chemist here, so though I can do syntheses, I don't always understand specifically the quantum mechanics behind it. That being said, though, what we are doing here is a displacement reaction. It may even be a double displacement because there are actually two ions being displaced here. The one is the iodine ion, and the other one is the nitronium ion, which is in our lead nitrate here. And so basically what is happening is the iodine from the potassium iodide is being released into solution. So is the nitronium ion, which is the NO3 part of the lead nitrate. They're both being released into solution and then reconnected to the other product. So what we are making here is lead iodide. That is our target chemical. However, in doing so, we are also making potassium nitrate because we're taking the nitronium ion off of this and it grabs a hold of the potassium, and we are taking the iodide or the iodine atom off of the potassium iodide and attaching it to our lead. Therefore, I believe this is a double displacement reaction because you have two different, well, you have an atom and an ion, two separate ones being displaced. It could just be a single displacement reaction. If anybody would like to correct me, please feel free to put it in the comments section and I will stand corrected most humbly. I am trying to learn as much about chemistry as I possibly can, so I do not want to be putting misinformation out there, and I also want to know for my own benefit exactly what is going on here. So I will quit rambling for a little while. We're just going to wait for our water to heat up, and once it gets hot enough, then we can start our reaction. That being said, though, it does not need to be hot before we add in our potassium iodide. We can do that, so I'm going to grab a stir bar here and I'm going to place that into our beaker, and we'll go ahead and we will add in our potassium iodide. Just stir that up a little bit. Come on, guy, there you go. Now, my stir plate here is half broken. That's why the stir bar keeps decoupling, as you see. Should not do that. One of the reasons why I am trying to get patrons via my Patreon page so that I can replace equipment such as this magnetic stirrer and hot plate you see here. It only half works. Anyhow, once the water heats up all the way, we will come back and we will start to add the fun part, which is the lead salt. Alright guys, our water is now up to 90 degrees Celsius. which is plenty hot enough. Put on a glove here since I am handling lead salts, and they are very toxic. See, I've got a stir bar in here, and I've got it going. I had to actually switch to my broken hot plate that only works as a stir plate, because for some reason, and I'm not quite sure why, my semi-working hot plate, every time I try to stir it, it decouples. So I guess that is my next thing on my list, is I need to get a new magnetic stirring hot plate. Joy. Anyhow, so you see I have the stir bar in there going, and so with the stirring, we'll start to add our nitrate salt, which is lead nitrate, and you should notice almost immediately, there it is, you see that yellow color precipitating? That's what you want. And now it looks like it cleared up. Really it didn't. It is just worked its way through the solution enough that the yellow is not as apparent. But as we add more of our nitrate salt, see the yellow comes right back out. So we'll dump all of it in. So now you can see it is a nice bright yellow color. I'm going to turn the stirring up just a little bit to make sure that this all gets stirred together. Now, the real beauty in this experiment is what happens as it cools. And in order for it to happen the best possible way, you want your solution to cool down as slow as possible. Hence, just leave it sit there with the ambient temperature hitting it, and periodically come back and take a look at it. So this experiment is commonly known as a golden rain experiment, and that is because as it starts to cool, you will start to see the lead iodide precipitating out in little tiny gold flakes, and it looks like it is just raining down through the container. So I've got this stirred up enough. Go ahead and we'll turn the stirring off. Move our stir bar. And so I'm just going to set this off to the side and let it cool. And when the effect that we are going for starts to happen, I will come back and I will show you guys what it looks like. Okay guys, you can see here it is cooling down, and you see all the stuff swirling around in there. That is actually our lead iodide, and it will precipitate and collect down onto the bottom. So this is really pretty to look at just as it is cooling. However, the final dried product is actually really awesome to look at too. For somebody that is really stupid, you could probably fool them into thinking it is gold. And so I'm not going to go ahead and dry out this run that I just made here because it will take a long time. However, I'm going to show you guys a batch that I had made previously so that you can see what it looks like once it has all been dried, and it looks pretty cool. Okay, so here I've got a little vial of it, and you can just see how shimmery it is in the vial. And let me just dump some out here on this white paper. You'll really get a good feel for what this stuff looks like and why people can be tricked into thinking that it is gold. Okay, so there we have it. That is lead iodide. Just gorgeous, isn't it? And this is as close as chemists have been able to get to the age-old quandary of, can I turn lead into gold? Well, even with modern technology, as far as I know, we have not been able to do so straightforward, but this is a way that you can turn lead into a gold-looking substance anyhow. So I believe this is probably as close as we are going to get. Let me see if I can, yeah, so you can see what it looks like when we zoom out on it. But obviously, closer you get, the more brilliant and beautiful it looks. Almost as reminiscent of fool's gold. Now, last thing I will say here is the reason why I made it such a small batch to show you guys is for the simple fact that if you make too much of this at once, instead of getting nice shimmery golden pieces like you see here, you actually end up just with a bright yellow powder, and it loses all of the shimmery attributes to it that you are seeing here. So even though it is the same product, I feel for aesthetic purposes that making it in smaller batches to obtain this nice shimmery looking product is just a lot more interesting and prettier to look at. So I hope you guys enjoyed the synthesis. It was a pretty basic one. Again, like I said, it's not entirely useful, but it is just fun to make and fun to look at. If anybody does have an answer for me, whether this is a single or double displacement reaction, I would love to know, so please post it in my comments. And again, I will have a link to my Patreon page posted in the description. So if anybody would like to help support me in making these videos, you can become my patron, one of my patrons anyhow. And you will see your name appear at the end of my videos. And that's about all it is for, or all there is, I should say, for lead iodide. Hope you guys enjoyed it. Thanks for watching.